Hi guys, and welcome to video 28 in the But How Do It Know companion video series. Today we're going to be adding the flags register and the conditional jump circuitry to our project board. The flags register is going to occupy this space here and the jump circuitry around here. So there's a lot going on in this build and it's a bit cramped, so I made two schematics to make sure that everything is clear. Let's go look at them. So in this schematic, there is really three different parts that we're going to look at. The first part that is in blue, the second part in purple, and the last part that is in yellow. So let's start with the simplest one, which is the part in blue, the flags register. So to store the values of our ALU flags in order to be able to use them later in conditional jump instructions, we use just a regular register like we've been using since the beginning of the project. So we have an SN74HC373 chip there. You can see that its enable signal is tied to ground because we want it to be always enabled. And you can see on the top right of the register its set signal, and if you follow it, it sort of snakes down through the schematic all the way to the bottom where you see a label named flags S. So this is a regular control signal just like all the other ones in our control section. Before continuing, remove the 4 blue LEDs and their resistors as well as the temporary wiring that's there. After that, we have our 4 flags that are coming out of the second Arduino to the left. They go into 4 distinct inputs of the register, and the corresponding outputs come out to the LEDs. And you can see below there is a label for each one, C, A, E, and Z. So all this is detailed in the book on page 133, and if you look closely at that, you can see that the carry bit that comes from the flags register is actually sent right back into the ALU. In this diagram here, it is the 5th blue wire, just a bit below the C label. And you can see here that that's not the case, right? We've sort of undid this connection, and the reason for that is that there are 2 bugs related to the way that this is set up in John's original design, and they are detailed in the errata page on his website. So I will put that down below in the description box. So the 2 bugs are basically as such. First, if the carry bit is sent right back into the ALU, that means that it is always available. And when we use the ALU to increment our instruction address register, if it is set, it will take effect there, and it will cause our IAR to increment by 2. Secondly, when the ALU is actually performing its operation, the signals go through these chips so fast that if you have an operation that sets the carry bit, it will feed back right back into itself and may cause the answer to increment by 1 another time and affect the result. So in order to work around those bugs, in the errata you will see John suggests to use a 1-bit memory that you can see here. It's the first SN74HC00 chip to store basically the carry bit when before we do an ALU operation, and then enable it using an enabler right to the right of it. That's the second SN74HC chip when we want to get it. So that adds a new control signal. You can see the purple wire going all the way down to the bottom there, called CTMPE. So basically when we do an ALU operation, in step 4, when we set TMPS at the same time, you can see there is a purple wire there that extends the TMPS line. So when we set TMPS, we save whatever carry bit is there. And later in step 5, when we need that carry bit, we set the CTMPE signal to recuperate it. So that way there is no timing issues and we can control everything tightly. And finally, to the right, we have the conditional jump circuitry that is described on page 134 in the book. So we have the last 4 bits of the IR. each is being sent to a different AND gate. So you see there is an SN74HC08 chip here, which contains AND gates. And the result of these 4 AND gates are all connected together and are ORed using the SN74HC32 chip that is there to the right to produce a final signal, which we will call the jump signal, which goes back into the 4th Arduino. So the way this is going to work is when we have a conditional jump instruction, whatever it is, we are going to set a new control signal called JCAEZ. You can see there on the lower right. And this is going to tell our Arduino, I am doing a conditional jump instruction. And whenever that last signal that comes from the OR gate there, if that signal is true, it indicates that we must do the jump. And if it is false, it indicates that we must not. So that is how we are going to be implementing conditional jumps. So the only thing that's missing here is to connect the actual outputs of the flags register to those AND gates that are there on the right and basically complete our loop. And that is what we see here in this second schematic. So I used 2 schematics just because there is overlap amongst all these things, and it becomes very hard to see if we put them all together on the same diagram. So basically you will have 1 wire going from each of the outputs of the flags register and into a different AND gate in our SN74HC08 chip, where it will be ANDed with the corresponding bit from the instruction register. So that completes this part of the build. So I'm going to take a little break here and go set that up, and we'll see what it looks like. So this is the completed build. So we have our flags register up here. We have the errata circuitry here. As you can see, I've used blue wire here instead of purple. The idea of using purple wire in the schematic was just to clearly differentiate the flags register circuitry from the errata one. So when we build it, we can use the same color of wire. We have our flag signals here going all the way up to our conditional jump circuitry. Everything is connected here. Our conditional jump signal is here, and our JCON control signal coming up from the bottom here into our Arduino. So the next thing we would need to do here is to actually create a program that uses a conditional jump to make sure that our circuit is working properly and test it out. But instead of doing a manual program like we did before, we're going to take a little sidetrack here. We're going to go look at I/O instructions and I/O devices, and that's going to allow us to view much better what's going on in our programs by making use of the Arduino serial monitor by way of an I/O device. And also we're going to look at the assembly language that I've created to make programming the computer much easier. And then we'll write our own test program to test our conditional jump circuitry directly in the Arduino. I'll see you soon.